Hello and welcome to a ramble about the departments, May 2022, paper 2, question 9.2, the second last question for the series for now. In the diagram, the diagonals of parallelogram KLMN, so the diagonals intersect at P. NM is produced to S, so it's extended to S. R is a point on KL, and RS cuts PL at T. The ratio of NM to MS is 4:1. NL is 32 units and TL is 12 units. There is a lot going on, y'all. There is a lot that is happening. Okay, I'm just going to write down this information because I am definitely going to forget some piece. So let's start with this piece of information here. Okay, not quite the thickness I'm going for. Oops, okay, maybe that's a bit too much. Right, so NM to MS is 4:1. So the way that I will write that is if MS is K units long, then NM is 4K units long. And I'm just going to highlight that in pink so that I can match it with the information that I've written up there. Okay, good. Then we're told that NL is 32 units. So I'm just going to highlight that in blue. Okay, and then, okay, I'll also highlight the piece of information where it appeared. And then TL is 12 units. Okay, yeah, it's a bit random. Okay, it didn't really want you sitting right on top of it. Okay, happy with that. Move you somewhere. This thing of it trying to, sometimes clever technology when it's being too clever and you're just like, hey, just sit where I want you to sit. Oh, they did write the 12 for us. Oops. Okay, very well. So I'll just highlight it and then highlight the information as well for myself. Okay, cool. Right. And in other words, then NT is 20. So that 20 plus 12 gives us the 32. Right. Determine with reasons the value of the ratio NP to PT in simplest form. We also have parallelograms going on here, so we've got lots of parallel sides. And if we're being asked to find ratios of sides, it's giving similar triangles. So let's see here. PT and NP are part of this system. Are these sides parallel? No one said so. No one said so. Absolutely no one said so. Um, yeah. How else can I find the ratio between these? Oh, no. I was about to say 4:1, but that would rely on these two triangles being similar, and for them to be similar, well, I'm tempted to say I need to know that these are parallel, but is it possible for me to know that their angles are the same without them being parallel? I don't think so. I don't think so. Let's see. NP and PT. What else are they part of? So NP is part of this triangle. PT, okay, maybe it's easier to look at what PT is part of. PT is part of something going on there. PT is part of something going on here. PT is, yeah, in terms of triangles, I think that's all that's going on for PT. There's this going on as well. But okusalayo, we don't know that these are parallel. And there's nothing special about the diagonals of parallelograms, is there? I think they bisect each other, but they're not necessarily equal. So let's see. We don't know how long this is. We know how long this is. We know that this whole side is 20. And that's about it. And I think the next question is about proving that Km is parallel to RS. So it makes me feel like finding the ratio shouldn't involve me proving that these are parallel. So was it gonna be Shimamamamama? Wada dee, shoo-doo-doo. You know, something I realized when I was playing back one of my videos is that the singing really doesn't seem to work anymore with the mic. So for those of you who have been annoyed by my singing, I'm gonna have to phase it out. You can rejoice. Your day has come. Um, so we know that parallelogram opposite sides are equal. So this 4K would also be a 4K here, whatever it is. Yeah, I don't think we're really achieving anything here. I mean, it feels like the answer should be 4 to 1, just because that ratio is also 4 to 1. But how? How, sway? How? So we have, I'm aimless at this point, guys. I'm stabbing in the dark. We have these parallel lines, meaning that this angle is equal to this angle. Um, this angle is equal to this angle, also alternate angles. And of course, this angle is equal to this angle, vertically opposite angles. Um, oh my goodness. Oh. Guys, revise your knowledge of the properties of quadrilaterals. Okay, so this is 32 units long. This is 12 units long. We know that diagonals of a parallelogram bisect each other, literally said this. So that means that this piece over here is 16, and this piece over here is going to, well, this whole thing is going to be 16, and then this will be what will be left when you take away the 12. So let us talk about it, okay? NP is equal to PL, and this is because diagonals of parallelogram K, L, M, N bisect each other. Okay, right. And so therefore, NP and PL are both equal to half of 32, which is 16 units. Okay, so now we've got NP, and therefore PT is equal to PL minus TL, which is 16 minus 12, which is 4 units. Yo, yeah, no, that was a proper workout. So the ratio of NP to PT is 16 to 4, which simplifies to 4 to 1, which is indeed as we suspected, 4 to 1, 4 to 1. Beautiful. Um, so let's duplicate this guy. Right. Hey, where did all my beautiful highlights go? Oh no. Oh my GeoSH. Why did the highlights remain behind? Somebody tell me why the highlights remained behind. Okay, we're just going to say copy and then try again over here. Okay, it's not great, but the technology is trying. Ish, everything moved out. Really? Something like that. Oops. Oh, the technology sometimes. Yeah, even this moved up. My word. Okay, right. Prove with reasons that your Km is parallel to Rs. Km is parallel to Rs. We would prove that by doing what again? Does the fact that this guy is splitting these by the same ratio, does that prove that they're parallel? I think it does. Let me double check. This is one of those theorems that I just keep forgetting. It didn't make an impression on me in high school. Ah, sorry, theorem. I just have to tell it like it is. When would we have learned this? Do you learn this in grade 12 or in grade 11? Let's try grade 12. Similar. I'm still singing. I'm still singing. Sure. I don't know what it's going to take for me to stop singing. Will I ever stop singing? Okay. Hey, what? Okay. Clearly not that. Did not find what I was looking for. Let me look in grade 11. Euclidean geometry. Wait, guys. Where are the mafunky funky? Okay, so Euclidean geometry is just about circles. Linear programming. Is linear programming back? What? Linear programming is back? What? Oh my word. Is linear programming really back? Wowzers with trousers. And now, have we gotten rid of the similarity, this thing that I just used now? So we talk about similar processes now, grade 12. Okay, maybe it's in grade 10. Guys, can someone please confirm in the comments, is linear programming back? Or is the textbook that I'm looking at outdated? I don't know why I'm so shocked. I have no beef. I have no beef with linear programming. No beef whatsoever. Um, it's a cool section, honestly. Get me trying to be friends with linear programming. Midpoint theorem. Not quite what we're looking for. Hula is loading, 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 loading. It has loaded, but it is not showing me what I want to see. Okay, I don't know what's going on. I genuinely do not know what's going on. So what shall I ask? If a line splits two sides of triangle in same proportion. Yeah, I think this is a thing. And then you say something about that side. If a line splits two sides of triangle in same proportion, is it parallel to the third side? To those of you who are so diligent and know your theorems, I'm so sorry. This has gone on for way too long. Siavula says yes, and it is there in the grade 12 section under triangles. What Modim? Was I not just here? I guess I didn't look under triangles. I looked under similarity. Okay. Okay. So the theorem, the proportion theorem says a line drawn parallel to one side of a triangle divides the other two sides of the triangle in the same proportion. And then the converse says if there's this line that divides two sides of the triangle in the same proportion, then that line must be parallel to the third side. Okay. She's Louise, man. That took way too long. Okay. So we're going to say simply KM is parallel to RS because line divides sides of triangle NTS in proportion. Okay, because we showed that the ratio of NP to PT is the same as the ratio of NM to MS. So we now know that NM, no man, KM is parallel to RS. So let us go forth and see what conquests we need to get to next. Let's see if I paste this image, what happens. Okay, that's a bit better. Things don't move around then. That's pretty cool. Okay, right. If NM is 21 units, determine with reasons the length of RL. So we know that the relationship is that NM and KL are equal because parallelogram things. As for RL, ungenapi. Oh, 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 oh. So this is another useful shape to look out for when dealing with similar triangles. This is definitely a popular shape, but this one is also a nice one where you've got the parallel sides and the crisscross situation happening, because then you've got vertically opposite, you've got alternate, and then you've got another alternate. So these are similar triangles. So if we know the length of NM, we also then know the length of MS because of the 4-to-1 relationship. So then we know the length of this side. We know the length of that side. So we might be able to get something yana going there by ratios. We also know the length of this side, right? Yeah. Okay, so we can definitely set up a ratio situation, something, because this side is going to be the twin of this side. Right, so let's prove they're similar first. In triangle NST and triangle RLT, okay, we know that angle NTS, okay, so I'll just highlight them as I go. So that guy over there, maybe we'll use a different color, shall we not? And thickness, guys, thickness. So angle NTS is equal to angle RLT. No, man, not RLT. RTL, which is this guy. Okay. Oopsie. Okay. And the reason for that is vertically opposite angles. Okay. Then we furthermore know that angle TNS, which is this guy, okay, is equal to angle RLT, which is that guy. And that is because alternate angles, KL is parallel to NS. And look, they didn't explicitly tell us that KL and NS are parallel. They just wrote it on the diagram for us, and we also know that it's true because we were told that KLMN is a parallelogram. So if you are a diligent student, unlike me, you would first state that KL is parallel to MNNS because opposite sides of parallelogram are parallel. So that's if you just want to be an extra sweet human being. You can do that. As for me, I am not in the business of being sweet. And then the last angle is um, angle TSN, which is that guy, okay, is equal to angle LRT, which is that guy, okay. And the reason you can say alternate angles again, you can say third angle of triangle, right? KL parallel to NS. Perfect. So now we can make our similarity statement. So this tells us that triangle TNS is similar to triangle TLR. Okay, TNS is similar to TLR. If I was clever, yes, I would have just highlighted which angles pair up with which angles. I'm just gonna circle the angles, and you go with that one. Okay, these colors are not very distinct, but anyway. And then you go with that one. Okay, yeah, these colors are really not distinct. Just circle them in blue. And okay, right, right, right. So, and the reason here is angle, angle, angle. Okay, so now we can set up our proportion statement, and that tells us Tn over TL is equal to, just keep the order for the sake of pettiness, Ns is equal to Ns over Lr, and then Ts over TR. And that's because of the similarity we just proved. Okay. Now let's fill in what we know. What are we trying to find actually? The length of RL. So this is the one we care about. Yeah, fine. I will release you shortly, iPad. Okay, and what do we know? We don't know TS. We know that NS, we know NM is 21. So ms is going to be a quarter of that. So let's fill in ns. So we're going to have 21 plus a quarter of 21, and then the LR or the RL that we're trying to find. And then we know TL, so let's get involved with that. We know that TL is 12. So now we need TN, and TN is going to be the 32 minus that guy. So TN is 32 minus 12. Then when I last thing, we don't really care about it. So this is going to be 20 over 12 is equal to 21. What's a quarter of 21? 5 and a quarter. Yep. So that will be 26 and a quarter over RL. And we can do our nifty cross multiply trick. So that will be 20 RL is equal to 26 and a quarter times 12. And then we divide both sides by 20. Okay. So then RL will be equal to 26, 26 and a quarter times 12 divided by 20. So that is 15,75,75 units. And that's that on that, y'all. Let's see what the memo has to say. Overall, not a very difficult question, but know thy theorems. Remember to learn the properties of your quadrilaterals. They could unlock doors you never thought they would be able to unlock. So yes, for the first question, we use the fact that diagonals of a parallelogram bisect each other in order to figure out the size of NP and PL. From there, we are able to work out the size of PT, and then we work out the ratio from there. For the next one, we use the fact that we use the fact that the ratios of the fact that line PM splits NT and NS in the same ratio. We use that to prove that the lines are in fact similar, not similar, parallel. So they explicitly write NP to PT is equal to NN to NS, which is very useful. I think that's a good thing to say, so that your teacher knows you're not just taking chances. And then for the last one, they use something called the prop theorem. I have no idea what the prop theorem is. Oh, I mean, I guess it's. Oh, these headphones are pinching my ears now. The proportional theorem is the reverse, well, not the reverse of the converse, but you know, of what we just spoke about. So if you have a line that divides two, not a line that is parallel to a third side, then it divides these two sides in the same proportion. How are they using that? So they say RL. Oh, they're using it in this system. So let's see. Okay. So they use the fact that this is the same as this. It's 21. We know the length of PT. So we know the ratio is going to be 12 to, I forgot what this number is, 4, 12 to 4. So that's 3 to 1. So then we need to split up the 21 in the ratio 3 to 1. So RL is basically 3/4 of 21. So let's just double check that. 3/4 of 21, which is 15,75. Okay, so just to go over that again, they use the fact that KL is equal to NM because opposites of a parallelogram are equal. Opposite sides of a parallelogram are equal. Okay, and we've been told that NM is 21, so this is also then 21. And then they use the fact that, okay, we know that this is 12 and this is 4 from previous calculations. And because these two sides are parallel, that means this line is splitting this side in the same proportion as it's splitting this side. So because we know the ratio of this piece to this piece, which is 12 to 4, then this ratio is also going to be 12 to 4, or if you simplify it, 3 to 1. So this side is 3/4 of this whole side. It's 3 out of the 4 parts. And because we know this is 21, we can just work out the length of RL to be 3/4 of 21. Nice. That's a cool way to do it too. Um, right. So, and also a shorter way. So that's very cool. Let's leave it at that for that. That makes no sense, but anyway. Signing out excitedly because I just have one question left for the night. I hope to see you there.